This video is just more practice for solving radical equations. To solve a radical equation, we first isolate the radical part and then we square both sides to get rid of the radical. In this first example, the radical is already isolated, so we can square both sides. The square root of x squared is just x. 9 squared is 81. It's really important to check all these equations because even if you do everything correctly, sometimes you come up with a solution that really doesn't work in the original equation. So we substitute 81 back into the original equation for x, and we do see that the square root of 9, 81 is 9, so this does check out. On number 2, we're going to square both sides of this equation. The square root of x squared is x. The square root of negative 2 is 4. Negative 2 times negative 2. When we check this, though, we try to put that 4 back in for x. The square root of 4 is not negative 2. This does not work. So this solution is no good. So in actual fact, this has no real solution. This usually happens, this kind of situation, when you square a negative number on this side. So make sure you're always checking your solutions. The square root of 2x equals 4. We're going to square both sides. The square root of 2x squared is 2x. The square root of 4 is 6. The square of 4 is 16. And then we isolate the x. We get x equals 8. When we check, we put the 8 back in there for x, and we find that the square root of 16 is 4, so this checks out. On number 4, we need to isolate this radical, so we're going to subtract 3 from both sides. We have the square root of x equals 4, and then we square. So x equals 16. And then we put it back in. We check. The square root of 16 plus 3 equals 7. Well, 4 plus 3 does equal 7, so this checks out. In number 5, the radical is already isolated, so we can just go ahead and square both sides. So we're going to have x plus 2 equals 9. 3 squared is 9. We subtract 2 to isolate the x. We get x equals 7. And then we check. Square root of 7 plus 2 equals 3. 7 plus 2 is 9. Square root of 9 is 3. So this checks out. On number 6, we're going to square both sides. We have x minus 7 equals 100. Then we add 7 to both sides. We get x equals 107. And we check. By substituting 107 for x in the original equation. 107 minus 7 is 100. The square root of 100 is 10. So 10 equals 10, and this checks out. On number 7, we can square both sides because the radical is already isolated. We have 2x minus 4 equals 36. And then we start solving. Add 4 to both sides. 2x equals 40, and then divide by 2. X equals 20. And then we check. Let's see. The square root of 2 times 20 minus 4 equals 6. 2 times 20 is 40. 40 minus 4 is 36. The square root of 36 is 6. So this checks out. On number 8, this radical is not isolated, so we need to add 6 to both sides. So the square root of x plus 1 equals 9, 3 plus 6. And then we're ready to square. So x plus 1 equals 81. Subtract that 1. We get x equals 80. So let's check. Square root of 80 plus 1 minus 6 equals 3. 80 plus 1 is 81. The square root of 81 is 9. 9 minus 6 is 3. So this does check out. Number 9. We're going to isolate this radical by subtracting 3 first. So the square root of 3x minus 14 equals 4. Square both sides. 3x minus 14 equals 16. And then isolate the x. So add 14. 3x equals 30. Divide by 3. X equals 10. Now we need to check. So we're going to scroll up a little bit here so we can check. X equals 10, so we're going to substitute 10 for x into the original equation. 3 times 10 is 30. 30 minus 14 is 16. So we have square root of 16 plus 3. Square root of 16 is 4. 4 plus 3 does equal 7. So that checks out. This page is just more. I think they're just starting to get a little more complicated, though. This radical is already isolated, so I'm going to square both sides. When I square the radical, I just get whatever the radicand was. When I square x, I get x squared. Well, this is a quadratic equation because of the x squareds. But when I try to make it equal 0, I need to subtract this x squared from this side and this x squared over here, and they end up canceling off. So I just end up with 2x minus 6 equals 0. And I'm just going to solve for x. By adding 6 to both sides, I get 2x equals 6, and then divide by 2, x equals 3. On number 11, we're going to square both sides. So we'll have x plus 4 equals, all right, do not forget, when you're squaring a binomial, you have to write the binomial twice and do double distribute or FOIL. Once you do that, you end up here with x squared minus 4x plus 4, which is a quadratic equation. So now I need to subtract all this stuff so I can make this quadratic equation equal 0. So we can subtract x and 4 at the same time. That gives us 0 on this side with x squared minus 5x, and these 4's cancel. So we just need to factor out a GCF here. That's the next step to solving a quadratic equation. Or you could use quadratic formula if you know it. So we end up with x equals 0 and x minus 5 equals 0, which says x equals 5. So we have two solutions, x equals 0 and x equals 5. However, when I try to check this, if I plug in 0 here, I have 0 plus 4 which is 4. The square root of 4 is 2. But when I plug in 0 here, 0 minus 2 is negative 2. These are not equal, so 0 is not a good solution. Let's try it with a 5. 5 plus 4 is 9. The square root of 9 is 3. 5 minus 2 is also 3. So 5 checks out as a good solution here. Let's try number 12. Number 12, we have two radicals, but they're both already isolated. So we're going to do this. That will give us 5x plus 6 equals 7x minus 6. And now we're just going to solve for x. I'm going to first put all my x's to the same side by subtracting that 5x. I have 6 equals 2x minus 6. And then I'm going to add 6, trying to isolate my x. So 12 equals 2x, divided by 2, we get x equals 6. Now let's see if it checks out. See if we do this mentally. 6. 6 times 5 is 30. 30 plus 6 is 36. The square root of 36 is 6. So this would come out to be 6. 7 plus 6 is 42. I'm sorry, 7 times 6 is 42. 42 minus 6 is 36, so this also comes out to 6. So this checks out fine. All right, in this example, this radical is isolated, but this one's not because it has a times 2 on it, but we're not going to be able to divide that 2 off because then it would pop up over here. So we're going to have to be careful with our squaring. This side will be fine. We'll have 5x plus 9. But over here, we're going to have to remember to square this 2, which is going to make a 4. And then the inside of the radical will just be times that 4. So we can distribute this. That'll be 12x plus 16 equals 5x plus 9. Now subtract the 5x to get the x's all to the same side. We have 7x plus 16 equals 9. Then move the 16 to the other side. So 7x equals negative 7. Divide by 7. Looks like x equals negative 1. Negative 7 divided by 7. All right, let's see. If we put negative 1 in here, 3 times negative 1 is negative 3. Negative 3 plus 4 is 1. The square root of 1 is 1. 2 times 1 is 2, so all of this comes out to be 2. 5 times negative 1 is negative 5, plus 9 is 4. The square root of 4 is 2, so this checks out all right. All right, we have one application geometry problem here. Solve for x, then find the length. The perimeter of the rectangle is 18 feet. So in the lesson, we used the perimeter formula, so we're going to go ahead and do that again. The perimeter formula for a rectangle is 2 times length plus 2 times width. We know the perimeter of this rectangle is 18. We know the length is the square root of 4x plus 8 coming from here. So this will be 2 times the square root of 4x minus 8 plus 2 times the width, which is 3. So now we just need to simplify. Okay, I'm going to try to isolate this radical by first subtracting this 6. So we have 12 equals 2 square root of 4x minus 8, and those are gone. Now we're going to divide by 2 to isolate this radical. So 6 equals, well, the 2 is gone now because these 2's cancel. So we have square root of 4x minus 8. And now we can square. Once you have that radical isolated, you can square. So 36 equals 4x minus 8. Now isolate that x by adding 8 to both sides. 36 plus 8 is 44. and then divide by 4 to isolate x. We get x equals 11. Alright, well that was the first part of the problem, because the directions say solve for x, which we did. X equals 11, and then find the length. The length is the square root of 4 times x minus 8. So the length is the square root of 4 times 11 minus 8. 4 times 11 is 44. 44 minus 8 is 36. The square root of 36 is 6. So the length equals 6